Alexandra Island, which is also known as Alexander I Island, Alexander I Land, Alexander Land, Alexander I Archipelago, and Zemlja Alexandra I, is the largest island of Antarctica. It lies in the Bellingshausen Sea west of Palmer Land, Antarctic Peninsula, from which it is separated by Marguerite Bay and George VI Sound. George VI ice shelf entirely fills George VI Sound and connects Alexandra Island to Palmer Land. The island partly surrounds Wilkins Sound, which lies to its west. Alexandra Island is about 390 kilometers long in a north-south direction, 80 kilometers wide in the north, and 240 kilometers wide in the south. Alexandra Island is the second largest uninhabited island in the world, after Devon Island. History. Alexandra Island was discovered on January 28, 1821 by a Russian expedition under Fabian Gottlieb von Bellingshausen, who named it Alexander I Land for the reigning Tsar Alexander I of Russia. The island was believed to be part of the Antarctic mainland until 1940. Its insular nature was proven in December 1940 by a two-person sledge party composed of Finn Ron and Carl Eklund of the United States Antarctic Service. In the 1950s, a British base administered as part of the British Antarctic Territory was constructed as Fossil Bluff. The island was claimed by the United Kingdom in 1908 as part of the British Antarctic Territory. Territorial claims have also been set by both Chile and Argentina. Currently, under the Antarctic Treaty, no claim has been officially recognized. The island contains the British Fossil Bluff Meteorological Center and refueling base. Geography. The surface of Alexandra Island is predominantly ice-covered. There exist some exposed nunataks and a few ice-free areas, i.e., ablation point massif, of significant size. The nunataks are the peaks of north-south trending mountain ranges and hills. They include the Colbert, Havre, Lassus, Rouen, Sophia University, and Walton Mountains, Staccato Peaks, Lally Foothills, Elgar Uplands, and Douglas Range. These mountains, peaks, hills, and uplands are surrounded by a permanent ice sheet which consists of glaciers that flow off of Alexandra Island. These glaciers flow west into the Bark and Wilkins ice shelves and Bellingshausen Sea, and east into the George VI ice shelf. The George VI ice shelf is fed by outlet glaciers from the ice cap on Palmer Land and Alexandra Island. Another notable feature of Alexandra Island is Hodgson Lake. It is a former subglacial lake that has emerged from under an ice sheet that covered it. It is 2 kilometers long by 1.5 kilometers, and has a 93.4 meters deep water column that lies sealed beneath a 3.6 to 4.0 meters thick perennial lake ice. The northern side of this lake is bounded by the Saturn Glacier, which flows east into George VI Sound, while the southern side of Hodgson Lake is bounded by the northern face of Citadel Bastion. During the last glacial maximum, Hodgson Lake was covered by the ice sheet at least 470 meters thick. This ice sheet started thinning about 13,500 years ago. It retreated and left Hodgson Lake covered by perennial ice sometime before 11,000 years ago. This lake has been covered by perennial ice since that time. Geology. Except for a 10 to 30 kilometers strip along its eastern edge, the bedrock beneath the ice sheet which covers Alexandra Island consists of a complex assemblage of metasedimentary and metavolcanic rocks. These rocks, which are locally overlain and intruded by igneous rocks, are known as the Limay group. Quote, It consists of turbiditic sandstone interbedded with secondary siltstone, mudstone, tuff, volcaniclastic sedimentary rock, agglomerate, and conglomerate, which have all been metamorphosed to prehnite pumpelite to blue schist facies. These metasedimentary rocks contain poorly preserved ammonites, pelecypods, gastropods, radiolarians, and fragmentary plant fossils. The Lemay group also contains north-south fault-band slices of accreted ocean floor, ocean islands and seamounts, which includes pillow basalts, volcaniclastic sedimentary rocks, and chert. The rocks, which comprise the Lemay group, are asymmetrically folded and thrust-faulted to the west, contain chaotic zones, and exhibit abundant coeval soft sediment deformation. Based upon biostratigraphy, the oldest known rocks found within the Lemay group are Lower Jurassic and range up to late Lower Cretaceous. The oldest rocks within this group may date back to Permo-Carboniferous times. The Lemay group is interpreted to be an accretionary prism that was built out from the west side of a long-lived magmatic arc, the roots of which are now exposed on the Antarctic Peninsula, between early Jurassic and Paleocene times when subduction ceased. The easternmost 10 to 30 kilometers wide strip of Alexandra Island is underlain by a 7 kilometers thick sequence of highly fossiliferous, shallow marine to subaerial fluvial sandstone, mudstone, and conglomerate of the fossil bluff group. The marine strata within the fossil bluff group contain numerous ammonites, belemnites, gastropods, pelecypods, and other marine fossils. The upper fluvial sedimentary rocks of the fossil bluff group contain fossil forests with standing trunks as tall as 5.5 meters, other plant fossils, and associated paleosols as found at Citadel Bastion. These sedimentary rocks are essentially unmetamorphosed and gently folded. They have been affected by strike slip, normal, and thrust faulting at different times, as determined from the fossils found in it. The fossil bluff group accumulated over a period of time ranging from early Jurassic to mid-Cretaceous. The sedimentary rocks of the fossil bluff group unconformably overly interfaulted against the Lemay group. Earth scientists argue that the fossil bluff group accumulated within a four-arc basin on the western side of a long-lived magmatic arc, the roots of which are now exposed along the Antarctic Peninsula. Two different groups of igneous rock have been found within Alexandra Island. One group of igneous rocks consist of volcanic and plutonic rocks of late Cretaceous to Paleocene age. They unconformably overly and intrude metasedimentary and other rocks of the Lemay group and the sedimentary rocks of the fossil bluff group. Some of these volcanic rocks consist of distinctive magnesium-rich andesites, which were created by the subduction of a segmented ancient mid-ocean ridge about 80 million years ago. Finally, there are several small outcrops of neogene alkaline volcanic rocks, which formed after the cessation of subduction. Gallery.